prediction of the cold dark matter theory is that the universe should be about 8 billion years old. Well, that's a big problem. We can determine the age of stars in our own galaxy, in the oldest globular clusters, both based on very well confirmed theories of the nuclear evolution of stars and spectroscopic observation. And the stars in our galaxy are 13 or 14 billion years old. So it's very embarrassing to have 14 billion year old stars in an 8 billion year old universe.
In addition, they went into dark energy. Now, why did dark energy come in? Because if you take the present value of the cosmological constant and the cosmological constant which came out of inflation, you find that they are not the same. Not only they are the same, but you have to find that the difference lies in something like 108 orders of magnitude. Now, can you imagine a physical theory getting the answers wrong by a factor 10 to the power 108? Yet, the Big Bang cosmologists very coolly accept this and simply put in another epicycle by saying that there is a dark energy which has changed over the time by this factor. So we have to accept that.
Dark energy is some force, again, unknown on Earth, unpredicted by any theory that we have validation of here on Earth, that causes an acceleration of the expansion of the universe. So as the universe is accelerating, and it's older than appears on the basis of the dark matter theory, and it's 15 billion years old. So we solve the problem of the age of the universe by hypothesizing yet a third completely ad hoc epicycle dark energy. So now we have a universe which is 70% dark energy, 28% dark matter, and only 2% matter that we can observe through our telescopes and here on Earth. Epicycle is being piled onto epicycle. And in the process, what we call the predictive power of the theory is fading away to nothing. One of the most destructive features of the methodology of the Big Bang is that it conveys the idea that only experts can understand the universe. Only people versed in extremely complicated mathematics can understand the universe. That if dark matter, dark energy appear to be incomprehensible or even nonsensical, it's because you don't understand the mathematics of these complex equations. This is, of course, the argument of the emperor's new clothes. If you can't see the emperor's new clothes, then you must be either stupid or incompetent.
So this goes on, and we can find that the old Greek tradition of epicycles, which was even adopted by Copernicus and has been continuing in standard Big Bang cosmology. If we go by the history, the Keplerian orbits, which were elliptical orbits, very cleanly and neatly resolved the problem of planets. And the circles upon circles idea had ultimately to crumble down. Now, in the same way, I suspect that the Big Bang theory will collapse under its own weight of assumptions, and a more neat theory, neat interpretation of the universe will emerge.
Does this mean that the age of the universe is not what Big Bang theorists have implied? Could the universe be eternal after all? How much are cosmologists really able to know?
We are now in a stage which can be called a plasma universe. And we are simply not privileged to know what stage the plasma universe evolved from. We do not have privilege to that information. We do not know. We will never know. And this is one major difference between the plasma universe cosmology and the Big Bang cosmology that claims to be closing in on the final answer.
The universe described by plasma cosmology is quite different. Here we are talking about a universe with no beginning and no end, an infinite universe, continuously evolving, an evolution that is continuously increasing at an ever rapid pace. It is a universe in which there is a coherence between what we can understand in the here and now on Earth and what we can understand in the rest of the universe. A universe in which there is no real limit to our ability to understand more new phenomena. And a universe in which we can apply what we learn in the universe in present-day technology.
The basic difference between plasma and all other forms of matter, that is solid liquids and gases, is that a plasma produces electromagnetic radiation and also tends to filament. So that we would expect in a simulation, which is what we see, in an experiment, which is what we see, we would expect to see throughout the cosmos a filamentary structure that is a spaghetti of currents intertwining the cosmos.
We can use plasma theory derived from experiments in the laboratory, from the basic concepts of plasma instabilities, from Maxwell's equations, and from the well-known laws of gravitation, to describe and predict how the structure of the universe came into being and what that structure is.